Hi, hello, this is your Lucky sir. So, now we'll go with thermodynamics. Thermodynamics concept building assignment. Thermodynamics is a chapter where students get lot of confusion. Being faculties, sometimes we only get some confusion. So, obviously, there is maximum possibility. So, you need to work on such kind of questions where you can improve your concepts. Such kind of questions, here I have taken around 100 questions. In 4 worksheets, we'll discuss all these 100 questions. Then we'll go with some numericals. Okay. All these are theory type of questions. Aram se. Okay, now take your time. Some 25 questions you take, around 20-25 minutes will take. A one by one question, one by one concept we'll discuss in detail with all examples. It is like a class. Okay, are you ready? Chalo, let's get into this. Thermodynamic terms, first point. Which of the following come under the view of thermodynamics? Okay. So thermodynamics says whether the reaction is possible or not. एक रिएक्शन होता है या नहीं होता है, इतना ही बताएगा वो. कब होगा, कितने बजे होगा, कितने टाइम में होगा. Rates we are not discussing. Whether the reaction possible or not. That is only given. So predicting the feasibility of chemical change is given by the thermodynamics. Extent of completion of the chemical change, rate, effect of temperature, all these are in chemical kinetics, not dynamics. Dynamics says only whether the reaction is possible or not. An isolated system is that in which isolated, okay na, open system, closed system and isolated system. Isolated system में there is no exchange of mass and energy. दोनों भी exchange हो गए तो open system. If mass is not exchangeable but energy is exchangeable, closed system. If both are not possible, both are not exchangeable, then that is isolated system. Option 3. A well stoppered thermos flask contains some ice cubes. This is an example of, okay na, a well stoppered thermos flask is isolated system. Means for some time, 1 or 2 hours, whatever the time we are going to keep, till that time, based on the flask, flask quality, the ice will be in the form of ice only. Flask for 6 hours, 8 hours, like that, temperature will be same, mass will be same. So that is an isolated system. A system which can exchange energy with the surroundings but no matter is called, okay, now that's called a closed system. Open means both matter and heat exchangeable. Here matter not, but heat is exchangeable, closed system. Both not possible is isolated system. Just now we were discussing. Examples: coffee, hot coffee in open cup, hot coffee in closed cup, hot coffee in ice flask. Okay, very simple examples. An intensive property of thermodynamics means a property which depends. Intensive means, okay, no, independent. It is not going to depend on the matter, size, quantity. Okay, no, it is not going to depend. So it is depending only on the nature of the substance, not on the amount, not on the amount is mentioned here, amount is mentioned here. So it depends on the nature. So this is the right option. Intensive properties like molar properties, freezing point, boiling point, these will be getting these in these questions. The intensive property among these quantities is density. For example, if you take density, 1 liter density, water density 1 gram per cc. Do you think that 2 liters density will be different? That means it is not going to depend on the quantities, on the amounts. So it is density. But mass, enthalpy, volume, they depend. They depend. Which is an extensive property of the system. Okay, now volume is an extensive property. It depends on the mass. Like if you take 16 grams of methane, 22.4 liters. And if you are taking 32 grams of methane, 44.8 liters. But yeah, volume. Okay. But temperature, viscosity, refractive index, or these are intensive properties. This is extensive. Thermodynamics conceptual assignment we are discussing. In which of the following sets all the properties belong to same category? All extensive or all intensive? You can see here. Here temperature is intensive. Specificity is intensive. Density is intensive. But here all are extensive. Okay, now enthalpy extensive, internal energy extensive, volume is also extensive. Extensive means they depend on the mass. Which of the following statements is correct? Okay, now correct statement is asking. Only internal energy is a state function but not work, because work is a path function. So this is the right statement. Only work is a state function, wrong statement. Both state functions, wrong statement. Both, so clearly showing, na? Simple. Remember, work and heat. Work and heat both are path functions. Remember only two. No need of remembering any others. Remaining all are state functions. They depend on initial state and final state. Which of the following statement is false? Clearly showing work is a path function, not a state function. Temperature is a state function, initial final states. Change of state is completely defined when initial and final states are specified, right? Work appears as the boundary of the system. Okay, now work appears at the boundary of the system, of course. A process in which no heat change takes place is called adiabatic process. Adiabatic process means system to surroundings. No heat exchanges are possible. Heat is not possible. Exchange of heat is not possible. System is not giving, surrounding is not taking, surrounding is not giving, system is not taking. That is adiabatic process. A gaseous system changes from a state P1, V1, T1 to another state P2, V2, T2, then to C, P3, V3, T3, and finally C to A. The whole process may be called. Okay, ना गोल होके आप फिर से वही जगह पे आ गए. You have started from your college. You went to theater, not interesting. You went to mall, not interesting. You went to college because my class is going on. Okay, fine. So college, theater, mall, and finally you came here, right? Means it is cyclic process. You came to the first point. In cyclic process, internal energy change is zero. That question we are going to get soon. Thermodynamics conceptual assignment by your lucky sir. So E, internal energy, H, enthalpy, heat changes, and first law. Based on this, some conceptual questions. On which of the following factors the internal energy depends? Internal energy depends on mass of the system. It depends on temperature of the system. It depends on nature of the system. So all of this. Internal energy means it is complete energy of the system. Whatever the inside energy is there because of vibrations, rotations, oscillations, atoms, molecules, nucleus, whatever the energy is there, that all energy is called internal energy. For a substance, more internal energy is observed in. Okay, now generally gaseous state, more internal energy will be there because in gaseous state molecules are apart from each other. Kinetic energy will be more. So molecules will be at a higher temperature. So definitely internal energy will be more. The total heat content of a system at constant pressure. This is the definition of enthalpy. Enthalpy is given by H. Calculation of H is not possible. We will go with delta H, change in enthalpy. And it is the definition. Total heat content of the system is delta H. Enthalpy H can be given as H is equals to E plus PV. This is the right expression. But H is equal to E plus PV. You cannot calculate HE. So we generally go with delta H is equals to delta E plus P delta V. Okay, now change in enthalpy, change in internal energy, change in volume at constant pressure. The enthalpy is maximum for, okay, now enthalpy is maximum for steam. Because as we know, steam is in vapor state, steam kinetic energy is more. So enthalpy will be more because volume change if you take, that volume is also change will be more for this occupies more space. Because of all these reasons, you can say enthalpy is maximum for steam. The expression of delta E by delta T, here you can see V is there. This V means it is at constant volume. So this is constant pressure, this is not correct. It is not enthalpy change, it is heat capacity at constant volume. Sorry for some spelling mistakes. Entropy, we didn't go to entropy till now. We'll discuss about entropy also. Entropy is disorder. We'll discuss about the disorder. The heat of reaction at constant volume. Constant volume is always delta E. Constant pressure is delta H. Constant volume delta E. Whenever bomb calorimeter question you see, bomb calorimeter, something you are saying, that means you are calculating delta E there because volume is constant. And all our reactions, exothermic reactions, endothermic reactions, chemical reactions, heat change, energy changes are given always in delta H positive, endothermic delta H negative, exothermic means all these are taken at constant pressure. So here answer is delta E because it is constant volume. 20th question. Which of the following relationship is correct for a reaction involving both reactants and products are in either solid or liquid state? Solid or liquid state means delta H is equals to delta E because the relation is delta H is equals to delta E plus delta N G RT. Gaseous state number of moles difference we are going to take. When no gases are there, delta H is equals to delta E because this term has no significance. The difference between delta H and delta E for the reaction. See here, BaCl to aqueous solution, K2SO4 aqueous solution. This is solid, you don't consider this, leave it. KCl aqueous solution. Okay, now all these are taken in aqueous solution or in the, what you say? So this is solid state, there is no need to consider. This is aqueous solution. How many moles of aqueous solution is there? 2 moles. And this is 1 mole, this is 1 mole. So difference in the aqueous solution moles is 0. So delta H minus delta E difference will be 0 because delta H is equals to delta E, delta N is equals to 0. Actually delta N we will take gaseous state only. Here this is aqueous solution, this is aqueous solution, this is solid state, this is aqueous solution. No need to consider any of this. Okay, now only gaseous state compounds we need to consider. Actually basically thermodynamics topic we discuss for ideal gases only. Okay, now the work done, whatever we are going to discuss, that is generally we discuss for ideal gas, even not real gases, ideal gases only. And here aqueous solutions and all are there. When this point comes in chemical equilibrium, there also we generally take delta N. Delta N is the number of moles of products minus number of moles of reactants in gaseous state. But if the system is in aqueous solution, there we consider the aqueous also. But here there is no need to consider. All these are aqueous and solid. So you can say that is 0. For which one of the following delta E, delta H? Delta H is equals to delta E plus delta nRT. Now what is saying? Delta E, delta H should be greater. That means delta N must be positive. In which case delta N is positive. Here you see number of moles are 2, products here 2 and 1. So minus 1. N2O2 2 moles, 2NO 2 moles, 2 minus 2 is equals to 0. Delta N I am writing. This is delta N, this is delta N. Here 2 moles and here 4 moles. 4 moles of products minus 2 moles of reactants, positive value. So this is your answer. H2, I2, 2HI, 2 moles and 2 moles is equals to 0. So 0. Okay. So this is your answer. What you need to check? He is asking delta H should be greater, means delta N must be positive. Hope you are enjoying thermodynamics assignment. When a reaction is conducted in an open vessel, the heat of reaction is represented as, open vessel means volume is not constant. Okay, now so pressure is constant. When you are taking pressure constant, that is delta H. That's why most of the reactions, not most of the reactions, all reactions we take delta H only because they are not at constant volume, they are at constant pressure. Atmospheric pressure, constant, so delta H. Which of the following holds good to the laws of thermodynamics for the reaction of C2H4, you see gas, 3O2 gas, CO2 gas, and this is liquid. He mentioned here liquid. See carefully, sometimes they mention gas also. Here, when this is liquid, number of moles of products are 2, number of moles of reactants are 3 plus 1, 4, so it is minus 2. Delta H is equals to delta E plus delta nRT. So delta H is equals to delta E, delta N value is minus 2 RT. Right. Coming to 25th question, we'll stop here. For which of the following reaction delta H is equals to delta E plus 2 RT? That means delta N value should be 2 plus 2. Here 2 and here 3 moles. 2 minus 3 is equal to minus 1. So this is not your option. It is solid, don't consider this one. 1 mole, 1 mole. 2 minus 0 is equals to 2. So this is your option. Here it is 2 moles. This is 2 moles. 2 minus 2 is equals to 0. Here it is 2 moles. It is 1 mole. So this is 1. So these are all not your options. This is your correct option. So this is thermodynamics worksheet 1. We'll continue with worksheet 2. In soon time I am going to upload. So it's your job. If you like, really you like, then you like. Okay, if you like, you like.